My name is Kornoelje, and I'm excited to be here at GraphQL Conference today. So the title of my talk is Choosing the Right Tool, GraphQL, TRPC, and Your Tech Toolbox. And I'd like to give a little background on why I chose that title. So I'm a software developer at Tecton, and at Tecton, we're an e-commerce company that sells wrenches, socket sets, screwdrivers, and more. So I'm on the web team there, and we're concerned about end user experience. We want to make a world-class shopping experience. And in order to do that, we need to go into our tech toolbox and pick the right tool for the job. And today we're at GraphQL Conference, so we're going to be talking about GraphQL, but primarily I'd like to give an introduction to TRPC and how to create Typesafe APIs with that. At the end of the talk, I hope that you'll have a great overview of TRPC and when you might use that tool and how it relates to the similarities and differences to GraphQL and how you might already be using GraphQL in your existing application. To give a little bit of background of myself, I've been a software developer for about 4 years. At Tecton, I lead site performance, so if the website is slow for any reason, just you can blame me for that. Like I said before, we're really concerned about end user experience and creating a world-class shopping experience. Like I said before, this talk will talk about GraphQL. I won't go into details about it, but I want to say straight up front that GraphQL is a fantastic specification for creating APIs, and TRPC is another tool that solves a similar but different use case. So without further ado, let's jump into the talk. And before I continue, I'd like to say a quick thank you to commercetools and HighGraph for presenting. If you'd like to hop in on the conversation, you can do so in the GraphQL Discord, and more information is available on GraphQLConf.org. All right, so let's get going. So the agenda for today's talk is primarily for developers who want to stay up to date on tools. So these are developers who want to stay up to date with what's happening in the world of technology and tools that are available to make our lives easier and end user experiences better. The primary focus of this talk is going to be describing the communication problem developers seek to solve on a daily basis. So this communication problem is primarily seen in server-client relationships, where a client needs to send and receive data from the server and display that to the end user. This is most commonly seen in SaaS applications or with e-commerce sites. Tecton being an e-commerce site, this is a problem that we look at and try and solve on a daily basis. The two main sections of this talk will be an introduction to TRPC, including a code demo, and then a comparison to GraphQL and how each of these tools fit into a specific use case in your SaaS platforms or e-commerce platforms. The focus of this talk will primarily be on web development, and you'll understand later why that is. So if you're not as familiar with web development, I still think this talk will be interesting, and I encourage you to stick around. All right, so as we get started, let's give a stronger definition of the communication problem. So let's say you're a software developer on a small team at a company who's either an e-commerce company or a SaaS platform. So you're on a small team, which means you're likely a full stack developer with 3 or 4 other developers. Likely this might be a web application. So if it's a web application, you'll likely have a TypeScript front end and back end stack. Because we're making a web app, we're probably using some sort of meta framework like Next.js or SvelteKit or Nuxt, which means we have a tightly coupled server and client relationship. And in a little bit, I'll get into why that tightly coupled relationship is important. With the application, we have a client and a server inside of our repository, and we need the client to communicate with the server and vice versa. So how do we do that? Well, to solve this communication problem, we have a couple goals in mind. We want the developers in our team to be able to iterate rapidly, creating new features for end users and solving bugs quickly. And we want to be able to do that with a high degree of confidence that we're making changes that are not breaking for our users and not breaking the user experience. One way to solve that is to leverage TypeScript and type safety that it gives us. So how do we leverage type safety to solve this communication problem, to encourage our developers to make needed changes, but have confidence when they're making those changes? A couple solutions I've seen and implemented myself is rolling your own REST API. So this offloads a lot of responsibility to your development team. You have to spend time setting up the sort of schema and communication layer, and deciding how you want that to happen. This can be great if you need a very specific use case, but also time consuming. Another example is OpenAPI for creating type-safe APIs, or GraphQL API. I think GraphQL is fantastic and I've used it in production before and absolutely love it. Another example is creating a TRPC API, which I'd like to go into a demonstration soon of what that is. Before I go any further, I'd like to say that this isn't going to be an introduction to creating a GraphQL API. If you'd like to learn more about GraphQL and using GraphQL with composable commerce, I recommend checking out Kelly's talk, in which he gives a fantastic description of what that is. All right, so what is TRPC? There's been a lot of lead up to this, so let's finally get into the meat of this. TRPC, this is a quote from their documentation, TRPC allows you to easily build and consume fully type-safe APIs without schemas or code generation. So that's a very broad statement with a lot of great facts in there. So let's unpack that a little bit. What does it mean to build and consume type-safe APIs? Well, TRPC stands for TypeScript Remote Procedure Calls. So this, you might be thinking of RPC from past that usually went over UDP or TCP communication layers. So it takes aspects of that, but TRPC works over HTTP rather than TCP. So you can think of a remote procedure call as a function on your backend, on your server, and that function just returns data and also communicates to a database. So you can call that function on your client and have it return data to that client. What does TRPC do? Well, we had some goals originally defined on one of our first slides that said, we want to empower our developers to have confidence when they're making changes. And in order to empower them, we're leveraging the ability of TypeScript to provide type safety when making full stack changes. TRPC allows you to seamlessly share types between your front end and back end without bloating your client code with unneeded JavaScript. How does this happen? Well, TypeScript has a really great aspect to it called type inference. And TRPC leans heavily into type inference. And in the demo, I'll be able to explain what I mean by that if you're unfamiliar. Because of this type inference, we can also support auto-completion in our editors, which gives our developers an easier way to call procedures on our backend from our client. And because of TypeScript, all of our front-end client code has a direct reference to backend code. So this makes debugging a breeze when you're making full stack changes. If you need to refactor an entire endpoint or procedure on your backend, you can do so with total confidence because TypeScript will warn you or elicit errors whenever you're making breaking changes to your backend. And because TRPC is function calls, just function calls on your server, it's very easy to add incrementally to your existing brownfield application. You can just add anytime you need a new endpoint, a new procedure call, a new function call, and consume that on your client. So it's very easy to iteratively add to your application. Now for the fun part. Let's get into a demonstration of TRPC so we can understand how to leverage type safety. Over here, we have some code. We have client code on the left, server code on the right, and over here, we have the output application. So I took this code example from the TRPC documentation website, so you can check this out for yourself and follow along if you would like. So let's unpack what's going on here, and then we can talk about how type safety and type inference is being used to create a great developer experience. So over here on the left, we have our page, and we're calling the greeting procedure from our TRPC object, and we're running a query with an object as an argument, and that object contains one field, name, with the value client. So this is querying our backend and then returning the result on our front end. In our code, we're checking that data exists and then rendering out that data. Pretty straightforward. So to show how simple it is to update this query, let's change this to GraphQL Conf. Click Save, and you can see that the data returned from our server is updated instantly. Now let's take a look at the server code. Over here, we can see that we have an app router and a greeting procedure that contains input and a query. So let's define these different aspects of the TRPC API. The app router here can be thought of as an API handler, and your greeting procedure can be thought of as an API endpoint. So if you're familiar with creating REST APIs, a single procedure can be a single endpoint in your API. Each procedure will take an input that is validated and either a query or mutation that then can optionally return data. Similar to GraphQL resolvers, a query can be thought of as a resolver. All right, now let's look at the power of TypeScript that is creating this really great developer experience. So let's say over here in greeting on our client, we're interested in figuring out what's happening in this greeting procedure. So one awesome feature is that we can command click in Visual Studio Code or power click in whatever editor and step into this function definition. And because of TypeScript, we have a direct reference from on our front end to our backend code. So clicking on greeting will take us directly to the backend code where the greeting procedure is defined. And if we want to rename greeting to something else, we can use TypeScript's language features of renaming a symbol. So we can rename it from greeting to message. And then seamlessly across our application, all instances of the greeting procedure have now been updated to be called message. That includes all front-end queries and the backend procedures itself. And you can see we're still maintaining the same data that we did before, all with this new symbol renamed seamlessly. So now let's show the power of TypeScript by modifying our input on our server. So if we were to change this name object from name to text, that's great. However, how do we know that we're fixing this breaking change in all the necessary locations? Well, because we're leveraging type inference, all instances of this procedure now will have this updated type, and TypeScript will elicit errors wherever a mismatch exists. So we can see here, name no longer exists on this input object. And if we hover over input, we can see the shape of this object. You can see now the only field on here is text rather than name. So we can rename this to text. And then over in our client, we can also rename to text as well. And seamlessly, we've made a breaking full stack change, knowing that we've covered all of our edge cases. Because of this, we can make these changes that our users need and want. We can make it in record time, knowing with full confidence that we didn't miss any edge cases, and ship this feature out as soon as we need to our users. So I'll undo some of those changes, and I can show you some more awesome features. So let's say over here in our data, we don't know what exists on our result property. Well, we can hover over data and see that text is returned on this object. Let's say that we need to return something else. We'll add another return field on this object. We'll call this second, just say test. And now if I hover over the data object here, we can see now this object contains text and second. Notice that I didn't have to update any sort of schema anywhere and regenerate any types. The schema from TRPC is implicitly defined within the structure of your procedures and routers. So anytime you need to make a schema update, you just do it and consume that on the front end, and any sort of change will instantly cascade through your entire application. So there's no sort of pause and recompilation step needed in your schema. So if you're familiar with OpenAPI or GraphQL APIs that are leveraging TypeScript and creating typed schemas, you might be familiar with having to do a save and compile step through that. With TRPC, it just works because of the power of TypeScript and the TypeScript compiler. And let's say we wanted to add another field, third, and this one should be a number. So we add a number literal, and now we can see the object here is typed as number, and we can use that on our client code with ease. All right, so we've seen how we can leverage TypeScript going back and forth. So now let's define a query procedure. We can do so by adding another field to our router, and we'll call this one getUser. getUser. So on the T object, we will say T procedure, query, and we will have that return in what we will call our user object. So we'll define an ID for that user and a name for that user. Great, now we've just created a new getUser endpoint. So let's use that in our client code. This can be done simply by saying const getUser. We'll rename that to user, TRPC. And here on our TRPC object, you can see automatically all of our procedures, including 2 helpers for Next.js. We don't need to be concerned with these 2, but we can see our message procedure and our getUser procedure that we just created here already on the TRPC object without having to specify it anywhere else other than just writing it in our app router. So we can use auto completion to type getUser, query for that, and we will check that the data exists. So user data, and then we can use that down here in our code base or in our markup. So we can say user data name. Click save, and now we're receiving data from our new endpoint that we just created. And if we wanted to change name to something else, we could change name to username. We can do so with ease by using the symbol renaming. So we've changed this to username, and we can see in our backend code here, name has also been updated to username. Fantastic, fantastic. All right, so we've seen how to make a query. Let's make a mutation procedure. So again, we can just add another field to this object. Make sure you add in your commas there. And let's get started. So we can say update user, since we're going to do a mutation. So t.procedure, and let's add an input here. So one thing to note, for this input, I'm using Zod for input validation, but you can use any sort of input validation library that you wish. You could use Yup, you could use Joy, or you could even roll your own. But for the sake of this, we're just going to use Zod since that's what comes pre-installed on that StackBlitz demo. So we're going to be updating a name field on our user, and we've created that. So now let's create a mutation. And for now, we'll just return null for the sake of the demo. All right, so we have our input validation set up. So now let's access this input object. So we can do so using the parameters in the callback of the mutation function here. So we can type input here, and if I hover over that, we can see input is of an object with the field name of type string. Exactly what we have written here. So that's the power of TypeScript being able to do some type narrowing. So we can assert that if this passes, then we know the data is accurate here. All right, great. So we have our user object here. So for the sake of the demo, I'm going to pull this out into a locally scoped variable, and we can return user here. Then in this input, we will modify the user's name by modifying the user. So user equals user object and then input object, and we will return user. So one thing to note, this line here, this could be any sort of normal JavaScript or TypeScript function. Oftentimes, this will be fetching out to some database or another external service in order to persist data, run your business logic, all of that. For the sake of the demo, I'm just doing a very trivial example of updating data, but really, this can be any sort of JavaScript or TypeScript function call. All right, so now that we're mutating this user object, let's return it. And now let's access this on the client so we can actually mutate the data and see that in action. So we'll say const update user equals trpc. And on our trpc object, we have the update user procedure already available for us. And we can say use mutation. Boom, sweet. Simple as that. So now let's create a handler function. So handle update. And that will be a function. And on this function, we'll say update user, mutate. And the variables here are an object with name of type string. And this matches exactly up to this input validation object here. So we could change this to username. And then on this object, username is valid. However, username doesn't exist on our user object. So let's use the symbol remapping back to name. And you can see this change was created in our backend code, but cascaded through all usages of this mutate function, which is great for making these full stack applications, full stack changes to your full stack applications. Anyways, because we're doing some client-side caching, I'm just going to pull in utilities from TRPC. I won't go over what is going on here. You can check out the TRPC documentation at trpc.io for more information if you are curious about learning more about how this works. But for the sake, just know that we're going to invalidate our client-side cache using the invalidate function available to us. Great. So now let's set up this handler on a button. So let's create a button component here, and by rendering a button element, and we'll just say update, handle update. Perfect. And now when we click update, it should update. However, there seems to be an issue with the client-side cache over here. So this is what should be happening. And I can go into a reason later on as to why this might be happening. But just know that this is the simple approach to creating a mutation with TRPC. All right, awesome. So we saw a great demo of TRPC, and there's a lot of different vernacular here. So let's go through that. So we have the router object in TRPC. A router object, as I said before, is similar to your API handler on your REST API. We have procedures in TRPC. A procedure is a function call, and it can be thought of as an API endpoint. A procedure can be either a query or mutation. Validation is very important because this is how we use type guards in TypeScript to properly infer and assert the types of our input and output objects. So validation is very important. You can use Zod, Yup, Joy, or any of your own, or you can roll your own version as well. Anything that you want can be used for input validation. Types. So this is one part that I skipped over first because it's really, really important. So I didn't want to blow past this. So TypeScript is how we're able to do all of this magic auto-completion, symbol renaming, and it's what gives us this high degree of confidence when we're making these cross-stack changes or these full-stack changes. So types, we share the app router here from our server, and we import it in the client. So I'll show this over in the code so we can see this in action. All right, so if we click into where we're defining the TRPC objects on our client, you can see we're importing app router here in our client-side code. So app router is being exported from our server code. So this is important, where we have a type that's being imported in our client code from our server code. So we have server code running on our client. However, this is only a TypeScript type, meaning that when we compile the application, this connection on our client to our server code will be compiled out, meaning when we're running the application, there is no shared code between our client and our server. So that means there's no extra JavaScript bundled on your client code. That means the client has no idea, well, what is access on the server. But when we're in developer experience world, when we're editing our code, when we're writing these mutations and queries, that means that we have this strong type inference and we have auto-completion, symbol remapping, we have references to our backend directly in our front end, but only in the developer IDE, not in production. So this type here is how all of that magic happens. So it's incredibly important to have this type definition set up properly, but it's important to note that this is only a TypeScript type definition. So no JavaScript is being shared between the client and the server. And then finally, we have the client, which again is what's calling those procedures. All right. Part number 2 of the talk, comparison to GraphQL. So like I said at the beginning, it's very, very important to be using these tools with their intended use case. GraphQL is fantastic. TRPC is fantastic. They're different tools for different jobs. At Tekton, we sell a wide array of tools. Sure, you could be using wrenches for any sort of action, but you don't want to be using a wrench to hammer in something. That's why we have hammers. You use the tools best suited for each job. Same goes for GraphQL and TRPC. GraphQL has a sweet spot for large separated front-end and back-end teams. GraphQL was originally spec'd out by Facebook, and now it's their own organization. But it was created by a company who had thousands of developers and needed a way for their front-end teams and back-end teams to communicate effectively. GraphQL allows a common language and a contract to be written between the engineering teams at large organizations. GraphQL is also great if your front-end and back-end are written in different languages. GraphQL is language agnostic because of the specification, and that is fantastic for teams using different languages. One awesome aspect of GraphQL is how large the ecosystem is. Because of the large ecosystem, it means there's less risk when you're picking a technology like this. It has that corporate usage and corporate backing, meaning it's being used in production by some of the world's largest companies, and therefore it has a large ecosystem and is going to stay around for a long time. So if you're in the position to make these technological architectural decisions at a company, de-riskifying those decisions are really important, and picking GraphQL is a great option. However, let's look at the tool that is TRPC and its specific use cases. TRPC is fantastic because it's easy to version, meaning that you don't need to be storing your schema anywhere because it's implicitly defined where you define those procedures. The ramp off time for TRPC is much easier than something like GraphQL where you have a specific language. Because TRPC is just function calls, you can move those to a different service much more easily than, say, something like GraphQL. TRPC only has itself as a dependency, So you're only installing TRPC on your projects, where with GraphQL, if you want to get that type safety, you'll have to install many other tools and run those tool chains in order to generate your type safe schemas. And with TRPC, you get a faster feedback loop. You get all of your changes reflected right in your editor instantly when you're typing them. With something like GraphQL or other tools where you need to be regenerating schemas every time you make a change, that feedback loop gets strung out, so it makes iterating much more difficult. Some awesome things I wanted to quick call out: both GraphQL and TRPC work over HTTP and WebSockets, and both of them prevent overfetching of data, which is great for companies concerned about sending too much data to the client. Some things to call out: TRPC 10 is on its way. It's still in alpha state, so there might be a couple changes before that happens. Prior to TRPC 10, you could only have about 100 procedure calls before the TypeScript compiler would start to lag. Of course, there are some workarounds for that, but just know that TRPC 10 is on its way, and it provides a whole host of performance optimizations. You can also call TRPC directly from an external backend service, one that's not tied directly in the monorepo where you're writing your server code. So I'd like to describe who is behind TRPC. TRPC is very much a community-driven project. We have Alex, who's the creator and maintainer. His work was originally built on top of the proof of concept that was created by Colin, who created TRPC and used Zod as an input validator, but now you can use whatever you'd like. And his proof of concept was originally inspired by Obvious RPC, which was the first Typesafe API written with TypeScript. And so who is using TRPC? TRPC is still a very new project, but it's already receiving more than 60,000 downloads a week on NPM. This is relatively small compared to the 8 million GraphQL receives on NPM, let alone the number of other ecosystems GraphQL exists in. However, GraphQL is gaining popularity very rapidly. It has over 12,000 stars and 50 sponsors of TRPC, making it a very well financially supported open source project. It's supported by many companies and is used in production today. So I say this to encourage you to check it out if you're in the position to make these tooling decisions. And with that, I'd like to conclude the talk. To conclude, I'd like to say thank you for your time and attention. I hope that this gave you a great introduction of TRPC and how we can leverage the power of TypeScript to make the developer experience better. This is all so we can make the end user experience that much more seamless, and we can make changes that our users need more quickly, having a high degree of confidence when making those full stack changes. I hope that this introduction to TRPC encourages you to check it out. And I also hope that TRPC and tools like this encourage GraphQL and other existing tools to make their story around type safety much more seamless and easier to set up as a developer. I hope you enjoy the rest of the conference, and feel free to chat on Discord if you have any questions. Thank you.